Hello students. So in this video we are going to see the module 4 in the arithmetic part, the content beyond the syllabus. Okay. So in the arithmetic part, so far we have studied about all the different number system and about the carry look ahead adder and what is the use of fast adder and different multiplication algorithms for unsigned number as well as for the signed number, then the integer division. So in the integer division also we had like a non-restoring algorithm and the restoring algorithm, right? And all these operations we have done through the integer values, right? So all the integer addition, subtraction, multiplication and division we have concentrated on the module 4 in the arithmetic part. But here, what is content beyond the syllabus means in your syllabus they have mentioned only the integer operations, right? But now in this video we are going to learn how the floating point number operations will be carried out by the computer system. Alright. So that's why I'm calling this as a content beyond the syllabus. Okay. So the nextly, floating point numbers and its operations. So what is called as, first of all, the floating point number, right? So the number, actually this is the sample representation of the floating point number. So any floating point number, it should have the three different parts. The very first part will be the sign bit, right? Afterwards the exponent part, then the fractional Mandisa part, right? So here it is having 32-bit representation, right? So this is the sample representation having 24 bits of Mandisa and 7 bit of exponent and 1 bit of sign bit. Okay, and here the exponent always it will be represented by using the 2's complement form, and always the implied base will be 0. Okay, so 2 to the power we used to specify the 2's complement form of the exponent, right? So next we are going to see the IEEE notation, how the representation, how we are representing the single precision as well as the double precision floating point numbers. So here by the name itself it implies single precision means which is having only 32 bits. Okay, and the double precision means the double amount of data, that is the 64 bits, and both single precision as well as the double precision both are having the implied base of 2 only, right? So in the single precision 32 bits, how it is segregated means 23 bit of Mandisa, 8 bit of exponent, in excess 127 representation. Okay, and 1 bit will be the sign bit, and in the double precision 64 bits, in that 64 52 bits of Mandisa we have and 11 bit of exponent, in excess 1023 representation. Okay, so here all the fractional Mandisa with an implied binary point at immediate left. Okay, so this is the representation. This is common for both the 32 bit as well as the 64 bit. Anyway, first bit will be the sign bit, then 8 or 11 of exponent. So 8 means it is for single precision and 11 is for double precision method. And Mandisa, here we are having 23 bits of Mandisa in the single precision. In the double precision it is 52. Okay, next we are going to analyze what are the rules we are following to add the floating point numbers, right? So to add or to subtract or to multiply or divide, we need to follow certain rules here in the floating point numbers. Let us see. So this is the floating point arithmetic operations. So here we are having both addition as well as the subtraction operation and multiplication, then the division. Okay. So here I have the number called as 3.1415 with the base of 10 power 8 plus 1.19 with the base of 10 power 6. Okay, so here if you see the base 10 to the power 8 and here it is 10 to the power 6. So here there is a variation, right? So in this case, how to add these two floating point number? Okay, And here also, if you see, the same number only I have taken for both the multiplication as well as for division also. So how to perform the all the arithmetic operations here in the floating point. Okay, that is the point here. So I am going to show you the rules. What is the add sub rule, multiplication rule and division rule. Okay, so that easily we can add or easily we can perform all the arithmetic operations by using the floating point numbers, right? Okay, so what is the very first rule of add and sub means? We have to choose the number with the smaller exponent. Anyway, we will be having two numbers for addition or subtraction. We have to select the very first number as which is having the very smaller exponent. So in the example, it is 10 power 6, right? So we have to select and we have to shift its Mandisa right until the exponents of both the numbers are equal. Okay, so 10 to the power 6 and 10 to the power 8 means two bit positions we have to adjust in the right side. Okay, we have to shift its Mandisa. Then we have to perform addition or the subtraction of the mandisas according to the question, right? And we are adding or subtracting only the mandisa part, right? And we have to determine the sign of the result. Then final step is, this is common in all the operations, we have to normalize the value. Okay, so here we are having the normalization process. So inside the normalization, either we can truncate the value or we can round up the number of mandisa bits. Okay, so this is the floating point arithmetic addition and subtraction rule. Next, we are going to see the multiplication rule. So here the multiplication rule, we have to add the exponent. The exponent should be added and we have to subtract the bias. Okay, and multiply the mandisa and we have to find the sign of the result. We have to determine the sign of the result. Finally, we have to normalize the result. If it is necessary, we can normalize. Otherwise, we can directly go for the truncation or rounding operation of the mandisa. Okay, so this is the multiplication rule. And lastly, the division rule, floating point arithmetic division rule. So here we have to subtract the exponents and we have to add the bias. Okay, just opposite of the multiplication rule. There we will be adding the exponents and subtract the bias, but here it is subtract the exponents and add the bias and divide the mandisas, and we have to determine the sign of the result. Finally, we are normalizing and we are truncating or rounding of the mandisa of the result. Hope you have understood about the floating point arithmetic different rules which is followed to perform the arithmetic operations. Yes, thank you.